shop. It's been busy around here the last week or two, so I got to start off by apologizing for this episode, which is number 7, being so chopped up. But I just filmed a little here and there when I could, and when I put them together I couldn't remember what I said on the one before, so if I seemed like I'm repeating myself, that's why. I want to thank all of the subscribers, all of the comments, all the viewers. I mean, it's your channel. I really appreciate it, and I hope I can put out something here that'll be worth your while. My new shirt here is sort of a tribute to Adam Booth and his adventures with his KT mill. Keith Rucker's got one. It seems like about everybody on the machine shop channels have a KT machine. I probably could never afford one, so I'm going to stick with my old Brown & Sharpe here, where a rapid traverse means just cranking the handle backwards real fast, and with a flat belt drive on the feed. This episode is mainly concerned with getting the 1885 Brown & Sharpe on the line shaft, which was successful. I had a few surprises, but it worked out pretty well. In this video, I'm finished boring the small pulley to fit the transmission, and make up a belt for it, and remachine the top pulley to put a crown in it, and get it going, and it worked out pretty well. I hope you enjoy it. I got something in the mail from a viewer, name of Tom Simo. He had this kicking around that was too big for anything that he had, and it's a really nice tool holder. It's straight, and it's got quite a lot of rake on it. And when I first looked at it, I thought, wow, this will be really great for machining wood. If I have to make a pattern for a pulley or something. And it's brand new. I don't think it's ever been used. And I appreciate it, Tom. Thanks for watching. And you'll be seeing this in the future. Another thing that's upcoming is I bought a generator. And it's a new old stock Army surplus 28 volt 40 amp DC generator off a Jeep or a half track or something or other. And I don't know too much about it as far as the wiring goes. It's just got a single plug here with 3 pins in it, and it's got a spline where the pulley goes on. And if anybody knows anything about these generators, or where I can get a manual on it, or where I can get a pulley that'll fit this spline, it'll save a lot of messing around getting something to fit. But I want to run 12 volt lights in the shop here with it off the steam engine. So that's upcoming. And let's see, I guess that's about it. So we'll get right to it. Press the bushing with the rough diameter, inside diameter, into the pulley, and I've got the pulley mounted in the chuck and indicated in, and I was really amazed. It ran really true. So, but you never know. So, right now I'm boring this out to just a few thousandths under 1 inch, and then I'll run a reamer in there. This same old 1-inch reamer seemed to be working pretty good, so we'll try that. Over to the back gear. I gotta disengage this. Gear. That's about a 64 Thunder, so it leaves us a little bit to clean up with the reamer. I guess I should back up a little bit and explain a few things about old lathes that you might not know. A belt-driven lathe has a what they call a cone pulley or a step pulley. This has got 3 steps in it, and there are 3 matching steps up above on the counter shaft. So you can throw the belt off by hand and set it up on the next speed. It basically gives you 3 speeds here. Also, there's a thing called a back gear, and basically all it is a low range gear set here, and it's this gear back here. And this particular lathe has got 2-speed back gear. It's kind of unusual, but what happens is if you disengage this pulley from the spindle, now the pulley can spin free, and the spindle has this big gear on it up here at this end. So if you engage this gear set, then the power transmission runs from the spindle through these gears across the back, and then there's a small pinion up here that drives the big gear on the spindle, and that gives you quite a speed reduction. And on this one, there's actually 2 different gear sets here on the back gear, and it's kind of an ingenious thing that American had. It's a clutch arrangement that has a tapered sliding pin, and each one of these gears has like a brake shoe. It's just cast iron brake shoes, and when the bulge in that pin comes underneath this gear, say for instance, that shoe comes out and it engages it, and if you pull this lever all the way forward, it lets that pin drop down, and that relaxes the brake on that one and expands the brake on this little one here. So it's got a tremendously low back gear and low range, and for the longest time I wondered what it was for, and then I did a little research on it, and I found this is really an exotic thing. They call it a relieving lathe, and there was a gearbox right here where I have this little oil can mount that ran a drive shaft up to the cross slide with U-joints in it, and when you had it in that very low back gear, it would just be a couple of RPMs. It would actually run the cross slide in and out, timed with the spindle, in order to make relieve things like reamers and milling machine cutter teeth and that kind of thing. It would rough them out, and that's what they used it for. Well, the gearbox is long gone. So you would normally use the back gear for a real low speed with a reamer or a really big drill, or boring something really big where the surface speed per minute
feet per minute gets really big because it's way out away from the center. And you'd use the higher speeds, the higher speeds here, locked up direct for polishing or turning small diameter things. Okay, now we're ready to make up a belt for the milling machine. It takes a 2-inch belt. I ripped one up here that's about 2 1/4. It was actually a 4-inch belt, and I cut it down. You can cut it down really well with just a table saw if you have a fine blade, and just keep the blade up about 1 inch, and it does a really nice job of splitting leather. I got it cut to length, and we're going to put the laces in. I'm using a U3C12 clipper lace. It's got the little bar welded, spot welded to it to hold everything together, and I like these laces. It's a little smaller style than the ones I use on the other belts, but this is a single ply belt, and I like the single ply belts because they bend really easy over a small pulley. But this has got to be trimmed just a little bit. You could use any old thing to cut them. Should look pretty good. This is a clipper lace tool. Probably it says patent 1925. You can find these on eBay. They're around. I've liked this one. I've had it a long time. Okay. Very important to cut this square. I've got a actual clipper guillotine cutter here, but you can use anything. But if you don't have it quite square, the problem is, if you exaggeratedly, if you don't have this quite square, you've got one side of the belt that'll run tighter than the other side of the belt when it runs over the pulley, and a belt always wants to run toward the tight side of the pulley if it's out of line. That's why there's a crown in the center of a pulley, so that it'll run toward the center. But if you don't get this exactly square, it'll make the belt oscillate back and forth over the pulley and can cause you some problems. So you want to keep things as square as possible. Now this is an old belt. I can tell this is the side that was been run next to the pulley, because this is the side that's got the most cracks on it. And this belt's probably 100 years old, could very well be. I just put some neat's foot oil on it. It seems to be in nice shape. All you can do is try them and see how it goes. But I'm going to install the lace with a little wire tie on the outside of the belt. It doesn't really matter. I've run them both ways, but it just seems a little neater that way. You don't have to push this down in hard. Just hold it straight, and I'm kind of eyeballing it, and I got it perfectly straight, so it's laying on there, and it should work out straight. You don't have to get real crazy squeezing these either. Just bring it up snug. And there you go. Cut another one for this side. It's going to be right about there. Another thing too is you don't have to worry about indexing on these as far as trying to get them indexed to run straight. They just They just do. It's not worth the trouble to deal with that. Put this in there. As you can see, I didn't put this in last time, but it doesn't seem to make any difference most of the time. Okay. Put this one in here. In the old days, a lot of times you find their pin was made out of rawhide, and that worked very well. But Clipper has these little, they're plastic coated wires. The only thing is, you got to remember when you order laces, these are separate. They don't come with the laces. You got to buy some of these for whatever size lace you're using, because the eyes are different sizes. So there's that one. And that should work very nice. After a while, after this gets run a while, there are little grooves that form on your in your wire, and it really is quite hard to pull them out. I don't even bend them over anymore. They don't seem to work loose. All right. I have the milling machine set up with the belt, and I test ran it, and the belt just does not want to run in the middle of the pulley. I checked the alignment of the machine, the alignment of the pulleys, everything is square, true. So I got to looking at this pulley. This is on the line shaft, and I haven't used it until now. And I didn't do anything with it when I put it up there because it looked like somebody had machined it, and it was running pretty true. Problem is, they machined the crown out of it, and it's also got a very slight taper. If you hold a straightedge up here, you can see a little daylight in the center, so it's actually got a little bit of a sway in the middle of it, which flat belts just do not like. It wants to run out to the edge for no good reason at all. So I'm going to remachine this OD of this pulley, and I'm going to put just a little bit of a crown in it, probably about 1/4 inch per foot taper, and I'm going to use the taper attachment on the old American lathe. So I've got it set up in here on an arbor, which is just a piece of line shaft with the center hole in it, and put the big chuck back on it. And as you can see, it's pretty close to the capacity. I think it's 17.5 inches in diameter, and the lathe capacity is supposed to be 18 inches. So I can just about get my little finger between the way and the pulley. This is about the limit to what you can turn on this lathe. So this is a little bit different setup here with a boring bar, and I'm going to set up the taper attachment on it. I'll bring this around so you can see a little better. There's a slide. A lot of lathes have these. This is nothing special, American, but this slide here normally just runs along with the carriage, but if you clamp it down over at this end, then when the carriage moves, this moves with the carriage. This slide over here can be angled, and there's a scale right here. So what you do is you pull this bolt out, which disconnects the cross slide from the cross slide feed screw. There's a brass block that runs with an Acme thread on there, and this is actually what connects that to the cross slide. So when you take this bolt out, the cross slide is actually free to move back and forth. I can't move it, but that's what it is. So then after you set your taper for what you want it, and when you tighten this down, as it moves, this slide being an angle actually moves the cross slide back and forth, and it cuts the taper at the tool. And I had this set up for a pulley before, and it's 1/2 inch per foot. That's a little much. I'm going to back it down to 1/2 inch per foot. I'm going to back it down to start with 1/4 inch per foot, because I don't have a lot of material left on the rim of that pulley. This one up. Tighten this side. Okay. So what we will do then is we have to use the compound, which we can't do because I've got it at a screwy angle. Yeah, I had to change my setup a little bit here. I forgot the compound is what actually does the infeed because you don't have the cross slide engaged. So I give it about 30 degrees here. This is all set up. This is tight. And I ran it back and forth a couple times. Should be ready to go. I'm just going to sneak up on it and make some very light cuts across here till I can get it to break out at this diameter, at this distance, which is 1/2 the pulley. I don't want a real sharp ridge here. We'll file it off a little with the file. But just that little bit of a taper on each side of the center makes the belt run right up in the middle. Or should. We will see. Back off the compound a little bit, like every time, because if you just start cranking back on this, there's a certain amount of lost motion in the taper attachment, and it will mess up your cut that you just made. So I always back out. Take a note of the compound setting and back it off about 10 thousandths. Run the carriage back, and then set the compound back about where it was. And then you got all, when you come up to the cut, you've got all the slack taken out in that direction. And I'll give it another 6 or 7. I shifted the taper attachment over to the other side of 0. Move the tool over here. So now we're going to cut in this direction up to the center and put the other taper on. Well, there it is. The taper met right at the metal here. It's not a great surface finish because we're chattering a little bit because we're hung way out here. But it's just fine for a pulley. I just hit it with a little sandpaper, but you can see the amount of taper there is there. It's not much, but it's just enough to do the job. This is a rig for balancing pulleys or anything. I got the pulley here on an arbor. These things were basically for balancing grinding wheels on surface grinders and crankshaft grinders and things like that. I don't suppose this is really necessary, but I found some of these pulleys to be quite far out. You can see this one is got a heavy spot right where they added some weight. We'll start by taking some of that out. Well, here it is in its new color. Set up on the line shaft. Had a little trouble getting the belt lined up, but in the end it prevailed. The pulley didn't have much crown in it, so I remachined the pulley, put a little crown in it, and it runs pretty good. It doesn't run quite in the center of the pulley down on the bottom, but I think it will after the leather belt has run in a little bit. I'm set up to cut the next slot in my dividing head spacer, which will be the first job that this milling machine is done on under steam power. It's made the full circle. Undoubtedly, when it was built, it was intended to be run under steam power, because in 1885 there was nothing else other than water power. So it's made the full circle and it's come back.